if you remember, the history of the atom was in John Dalton in 1800. He discovered atoms and said that everything that has mass and volume is made up of atom, which is undivisible. But then came the J.J. Thompson, who in 1800 discovered electrons and gave the plum pudding model. Then this model was further revised in 1911 by Rutherford, who did the who built upon the alpha scattering experiment and discovered the nucleus. And then in 1914, Niels Bohr gave the idea of electronic shells. And in the end, James Chadwick in 1932 discovered the neutrons. And then finally, we came with the present structure of the atom, which consists of neutrons, protons, and electrons. So let us look at these discoveries one by one. The first discovery was J.J. Thompson. What he did was he took a glass tube and there he kept a gas at a very low pressure. And then in the glass tube, he had a cathode and an anode and gave him a very high voltage, around 150,000 volts. And at such a high voltage, he saw some rays coming and going towards the positive plate. And as soon as they were striking the positive plate, they are causing a green glow at the glass rod. So then he came to a conclusion that there are rays coming out of the cathode. He called them cathode rays. And since they were going towards the positive, he concluded that it is negatively charged. And he found that the atoms were actually giving off these rays. And that was the nature of them were the electrons. So he discovered that there are some negative and the positive charge elements present inside the atom. So he gave the idea of the electron and then he came up with the structure called the plum pudding model. Now what he said in a plum pudding model, he says that atom is the sphere of the positive charge, and inside this positive charge the electrons are embedded like a plum, and therefore he gave a plum pudding model. Now, if this theory was true, then what we should have expected is that when we pass the alpha particle, which is the helium particle, which is positively charged through this sphere, it should have deflected as the atom has positively charged equally distributed throughout. But what Rutherford found that this was an experiment done by Masten. When they passed the alpha particle through the gold foil, they saw that the most of the alpha particle passed straight through, and some showed deflection at a very great angle, and that was just at the center. So then they concluded that majority of the space in the atom is empty. And since there was a large deflection just at the center, so at the center we have what is the nucleus. So a nucleus is concentrated at the center. So the dense positively charged particles called the alpha particles were fired at the thinnest piece of the gold foil. Most of the alpha particle passed straight through the gold atoms. And with their diffuse cloud of positive charge, the Rutherford modified the structure of the J.J. Thompson, and he said that the positive charge is concentrated at the center is the nucleus, and the nucleus at the center consists of positive charge elements, and other electrons are just outside the nucleus. So therefore, he gave another structure with just nucleus at the center and electron surrounding around that. But then came another scientist called Niels Bohr. He said the electrons are not just randomly surrounding the nucleus, they are just moving in an electric shells. Okay, and then there was another scientist called James Chadwick. He saw that there's a difference in the structure of the mass of the atom, and the mass of the atom and the mass of the neutrons and electrons and the protons. So he found that there's a third element called neutron, which are present inside the nucleus, which have no charge. So the electric balance is maintained, but it accounts for the difference in mass of the atom. So they had mass but no charge. So therefore, we came up with the three subatomic particles, the electrons, protons, and neutrons. This table is very important. I stress in chemistry as well. So in electron, the charge is -1, proton is +1, neutron have no charge. On the other hand, the relative mass of the neutron is 1, proton is 1, and electron is 1 over 1000. The electrons are moving around the nucleus in shells. The protons and neutrons are in the nucleus. So if we draw one atomic structure, it comes up like this. At the center, you have this positively charged and the neutrons, and around you have the electrons which are going in the shells. Okay, so I hope this table, the discovery of the atom and how do we draw the structure of the atom, this should be clear to you. All right, okay, let's move ahead. Next, what we have is that how do you work out the proton, neutron, and an electron number? For every element you see in a periodic table, there's a symbol and the number at the top, which is the mass number. Number at the bottom is the atomic number. So if you want an electron number of any atom, then you write the bottom number, and the proton number and the electron number is the same. So the bottom number is also proton number. And for the neutron number, you do the top number, take away the bottom number, because the top number has both protons and neutrons together. Okay, and the last concept that we saw was isotopes. Isotopes are the members of the same element having same atomic number but different mass number, or it has same electron number, same proton number but different neutron number. As the electron number is the same, isotopes have similar chemical properties but they have different physical properties. So you should remember the definition of the isotopes. Okay, so this was a quick brief overview over what we did in the atomic structure in chemistry. Now let us come to the nuclear radiation. Now there are many nucleus of many atoms which are very unstable. Now in order to get stable, they either lose masses and charge. And how they do lose that? By giving off three radiations, alpha, beta, and gamma. You should know the nature of them and what they are. So alpha is a helium particle with the charge of 2 and mass 4. Beta is an electron with no mass and the charge -1, and gamma has no charge and no mass. So the alpha particles has the biggest mass and the heaviest. Beta has smallest mass, and gamma is just an electromagnetic radiation, so it has no mass. Alpha particle being heavy, it's least penetrating, beta is reasonable penetrating, and gamma is highly penetrating. Alpha, since it's very heavy, it's deflected slightly in an electric magnetic field. Beta is deflected at a greater angle, and gamma shows no deflection because it is at no charge. Since alpha is heaviest, it makes sense as well to have a low speed. Beta has a medium speed and gamma has a highest speed. And as alpha has the highest charge amongst all, so it should be highly ionizing. Beta is medium ionizing and gamma is again low ionizing. Okay, now the alpha can be stopped by paper, so it has least penetration. Beta can be stopped by aluminium. Gamma can be stopped by lead. So you should remember all these differences and these features of the alpha, beta, and gamma. Now every radioactive element shows a decay. So the number of decay per second is called the activity. So activity of the sample is the rate of decay. Now, the time it takes for the VDK to be half is known as the half-life. Now, you can get a question numerically as well as graphically in the exam. Numerical question would be if the half-life of a sample is 5 years and we started with the activity of 20 BQ. Then in 5 years, the activity will be 10 BQ. In another 5 years, it will be 5 BQ. And another year, it will be 2.5 BQ. That is in 15 years, from 20 BQ, it becomes 2.50 BQ. Now, in the exam, they can give you this graph and then they can ask you to find the half-life. Now, how will you find the half-life from this graph? You can see the maximum activity is 2.5. So half of this is 1.25. So look at 1.25, read it across, read the time. So we can get that the half-life is around 30 minutes. All right. So I hope this half-life, doing this numerically and graphically, is clear to you. Now, in the exam, they can give you nuclear equation. In the nuclear equation, remember, whenever the alpha particle is emitted, the mass number goes down by 4 and the atomic number by 2. In the beta, the mass number remains the same, but the atomic number increases by 1, and in gamma, no change. Basically, to make it easy to understand, make sure the top numbers to the left side should be equal to the top number at the right side. So for example, if this is 238 to the left side and 234 to the right side, then the other number has to be 4 to make the top numbers and the bottom numbers on both sides equal. So this is 92, 90, and 2 is 92. 30, so 31 minus 1 gives 30, 73 plus 0 is 73, okay? So in balancing nuclear equation, you just have to make sure that the atomic numbers and the mass numbers are same, or the sum of the atomic numbers and the mass number on each of the sides are same. So that is why whenever the alpha particle is emitted, the mass number, the atomic number, it decreases by 2 and the mass number by 4. In beta, the mass number shows no change, but the atomic number increases by 1, and in gamma, no change. So in the exam, They can give you the nuclear equation, ask you to find the missing element. For the missing element, work out the atomic number, come to the periodic table, and see what that atomic number element is. Now you should know the uses of the nuclear radiation. Now alpha is used in smoke detecting alarms. Why? How? Now this is alpha particles. You know alpha particles are highly ionizing. Ionizing means they can make anything charged by knocking off the electron. So all the air particles around it, they have become the negatively charged because of the ionizing power of the alpha, and there's a current that is being constituted in the room because of the ionization of the alpha particles, the air particles by the alpha particles. Now, as soon as the smoke comes in, what will happen? The smoke particle will stop the ionization and the current will cut off, and that will ring the alarm. Okay, so that is the principle of the smoke detecting alarms. So the alpha particles, due to ionizing power, ionizing the air particles, which then creates a current. During smoke, the current is disrupted as the smoke particles prevent the ionization of the air, which result in ringing of the alarm. Next we have is the thickness of the paper by a beta sheet. You can see this is a paper, and we have a beta source that is emitting a beta radiation and a beta detectors, and that is giving a feedback to the roller. Now if the radiations are taking a lot of time to come to the detector, then the detector will find out that the paper is actually thicker than what it is required. So depending on what the signals it is getting from a beta source, and if it is the radiations are taking bigger time or greater time, they will send the feedback to the roller that come closer to each other and make it more thin. So then the roller will come closer and be more thin. Okay, so this is how we can control the thickness of the paper or many metal sheets by beta. Okay, next is the gamma radiation. It has very diffuses. In medicine, it is used to kill tumor cells, cancer cells. Why? Because they have highly penetrating power. So due to this highly penetrating power, they can penetrate deep inside the tissues. We can have gamma cameras, which can take the pictures of the internal organs of the body. And the gamma radiation is emitted by the radioactive tracers. We put the radioactive tracer inside the body. The radiations that they emit, they help us to visualize the blocked organs like blocked kidneys of the body. Then it is used to sterilize the food. It is also used to visualize any blockage in the gas pipeline, to determine the weak points of the gas pipeline, and it is also used in the development of nuclear reactors and bombs. Okay, so I hope all these uses of gamma radiations are clear to you. Now the radioactive hazards are two. First is ionization. The process of knocking off the electrons and making the atom charges ionization, and alpha particles strongly ionizing, and if anybody is exposed to the alpha particle, they can ionize the DNA and cause damage to the cells and cause mutation. And at times, our particular matter or any atom can get contaminated with the radioactive element, and that will pose the risk of radioactivity. So that is known as radioactive contamination. Now, how we can prevent the hazards of radioactivity? We can limit the exposure of the workers in the radioactive facility. We can shield the space where the radioactive materials are kept. We should make sure proper dumping, proper storage, and proper use of radioactive materials. We should wear eye mask, protective shield, eye cover while working with the radioactive material. And we should also monitor the exposure to radiation, and people working in the radioactive facility, they should not be exposed for a greater amount of time. Okay, so I hope this is all clear to you. Now let's come to the last topic, the fission and fusion. Now nuclear fission is the way in which the nucleus is used to generate the electricity. There's a heavy atom called uranium. When the uranium is struck by a neutron, it breaks into two daughter nuclei and three more neutrons, releasing large amount of energy. These three neutrons can further hit another uranium and again split into two daughter nuclei and three neutrons, which in turn can further lead to other reaction, making the reaction go uncontrolled. And this is known as a chain reaction. So what is nuclear fusion? It is a process by which a bigger nuclei like uranium or plutonium breaks into a two daughter nuclei, releasing energy. Now, why it is a chain reaction? Because a fast-moving neutron hits the nucleus of the uranium atom. It breaks it into a two daughter nuclei, releasing three neutrons. Each of these three neutrons creates a further fission, releasing more neutrons, resulting in large amount of energy, constituting the chain reaction. Okay. Now, how do we use this nuclear fission? We use this in a nuclear reactor. Now, understand this. This is very important. You can see this is a reactor. Inside the reactors, we have fuel rods, which are made up of fissionable material called uranium and plutonium. The neutrons will be released into this reactor. They will hit more fuel rods and generate large amount of energy. Now this energy, we are pumping the water as well. Now this energy will convert the water into a steam. So you can see that the steam will come out. The water is pumped in, but the steam will come out. This steam will have a lot of energy, and that energy will be transferred to the turbines. The turbines will rotate and then generate electricity. And the water will be cooled down by the condenser, and this cooled water again be fed back into the reactor so that it can get converted into steam, run the turbines, and generate electricity. So here the nuclear energy, that is the energy in the uranium, is converted into the heat energy, which is converting the water into steam, and the steam has the kinetic energy, converting the energy into the kinetic energy of the turbines, and the turbines are generating the electricity. Now, what are the components of a nuclear reactor? We have fuel rods, control rods, coolant, and a moderator. The fuel rod is a rod of the fissionable material which undergoes fission, releasing neutrons into the other rods, causing the chain reaction. The control rods are here, which are made up of boron and cadmium. What do? They absorb the excess neutrons released by fission so that the chain reaction can be controlled. Then you have the coolant. The coolant is made up of water that will convert it into steam, and then that will run the turbine. And moderator is the heavy water which we put into the reactor that actually tries to slow down the neutrons so that they can be more efficient in carrying out the fission. Okay, so you should know the components of the reactor, this flow chart, how the reactor works, and the different components and their uses. Next comes the nuclear fusion, which happens naturally in the sun. So two protons, hydrogen, come together and form a bigger nuclei called the helium. Now, the problem with the fusion is it takes place at a high temperature. Why? Because when you bring two nucleus together, both being positively charged, they try to repel each other. So we need a large amount of energy to overcome the repulsion between the two nuclei. Therefore, it is difficult to build a fusion reactor as well. Otherwise, fusion is a very promising source of energy. Why? Because the raw materials like hydrogen is easily available. The waste is not radioactive. It do not produce any harmful or radioactive exposure. But the only problem is the high temperature is required to overcome the nuclear repulsion. So this is the difference between fission and fusion. In fission, the bigger nuclei breaks into smaller one. In fusion, small nuclei join to form a bigger one. In fission, there's a chain reaction. In fusion, no such chain reaction. In fission, raw materials are difficult to obtain. In fusion, raw material like hydrogens are easily available. Fission produces nuclear waste. Fusion, the waste is not nuclear. Fission does not occur naturally, and fusion occurs naturally. So you should be able to comment on the efficiency of fission and fusion and how they work in the exam. Okay, so I hope this unit is clear to you. Now let us look at the key terms. You can pause the video, have a go over these key terms, and now you should be able to define an alpha radiation, beta, gamma, radioactivity, half-life, activity, isotopes, atomic number, mass number, ionization, radioactive contamination, nuclear fission, fusion, chain reaction, moderator, and the nuclear reactor. Okay, so it's the time to test yourself. So the first question is distinguish between alpha, beta, and gamma. Then you need to complete this nuclear radiation equation. Then it says a radioactive substance have the half-life of 20 years. How much time it will take to reduce 1/6 of the original activity. How alpha is used in smoke detector. How beta can be used in measuring thickness. Use of gamma, and distinguish between fission and fusion. Pause the video, have a go over these questions, come back and check the answers. All right, now let's look at the answer. So let's just first balance this nuclear equation. Remember, I told you the numbers on the left side, the mass number and the atomic number should be equal. So it's 238 here. To the right, there's 234. So we are left over with 4. 92 is 90 plus 2. So 4 and 2 is the helium particle. Then nitrogen 4 and 7, 14 and 8. So the top number is already balanced. So the particle will have 0 at the top. And it is 7 and 8. So we have to do -1. So it's a beta particle. All right. So I hope number 2 is clear to you. For number 3, We start with 1. In one half-life, it will be half, second half-life a 4th, third half-life an 8th, and then fourth half-life a 16th. So for 1/16 of a value, we require 4 half-life. One half-life is 20 years. 4 half-life is 80 years. Okay. Now for distinguish between alpha, beta, and gamma, this is the difference. We have already discussed them in the slide, so you can go back and read that there, but make sure you remember all these differences. They are very, very important. Next is the use of alpha in the smoke detecting. We have already discussed this, how the ionizing power of the alpha makes it useful to be used in smoke detecting alarm. Next is thickness of paper by beta. That has also been explained, that the detector sends the feedback to the roller to come closer and monitor and control the thickness of the paper or the metal sheet. The gamma are used widely in medicine, foods, and development. We have also discussed that in the previous slides. And fission versus fusion, we have already discussed that fusion is more promising, but the higher temperature is a bigger issue. And for fission, controlling it and the radioactive waste is a bigger problem. Okay, so as always, what is our next step now? The next step now is check the specification, do the exam questions on this topic, make sure this topic is crystal clear to you. If there's anything that you still don't understand, leave a comment below or come to my website where I'm available 24/7 till your exam to make you understand anything which is not clear to you. Okay, now if you like this video, do subscribe to our channel and do not forget to like, comment, and share this video. Also, do not forget to click the bell icon at the bottom, because when you click on the bell icon, you will be notified as soon as I put any new video, and I always put the videos near to the exam that are really helpful for your revision. Okay, so I'll see you next in the next video. If there's any specific video, any specific topic you want me to make a video on, also leave a comment below, so I'll make sure I have that up before your exam. Okay, so I'll see you next in the next video. Till then, happy revising.